bombardment. The Late Heavy Bombardment, between 4.1 and 3.8 billion years ago, was a period when Earth was struck by waves of enormous asteroids and comets. Some impacts created craters thousands of kilometers wide, releasing energy so great that oceans boiled away into steam and entire sections of crust melted into magma. For long stretches, the surface was uninhabitable, and any fragile beginnings of life could only persist in shielded environments like deep underground rock or hydrothermal vents on the sea floor. We know this event happened because the Moon, with no atmosphere or plate tectonics, preserved the scars. Lunar rocks show clusters of impact ages matching this time, while tiny inclusions in Earth's oldest minerals carry traces of platinum, iridium, and other extraterrestrial elements delivered by impacts. Once the bombardment slowed, Earth's crust stabilized, oceans could stay intact, and conditions finally allowed life to expand across the planet. Oxygen crisis. Around 2.4 billion years ago, cyanobacteria began producing oxygen through photosynthesis. At first, this oxygen reacted with dissolved iron in the oceans, forming massive bands of iron oxide that we now see as banded iron formations. Once the iron supply was exhausted, oxygen began to accumulate in the atmosphere. For early microbes adapted to an oxygen-free world, this was toxic. Oxygen damaged their cell chemistry, causing one of the first global extinction events. The change also triggered climatic upheaval. Methane, a powerful greenhouse gas, was destroyed by oxygen, weakening the greenhouse effect and plunging Earth into one of its earliest ice ages. This event, known as the Great Oxidation Event, nearly ended life as it existed then, but also set the stage for complex organisms to evolve later. Snowball Earth. Between 720 and 635 million years ago, Earth underwent extreme glaciations where ice sheets spread from the poles to near the equator. Ocean surfaces froze, reflecting sunlight and amplifying the cold in a runaway feedback loop. Global temperatures may have dropped so low that most of Earth became locked in ice, earning the name Snowball Earth. Life in shallow seas was devastated, and ecosystems collapsed. Survival was only possible in refuges such as hydrothermal vents, cracks in the ice, or small regions of open water. Volcanic outgassing of carbon dioxide eventually built up in the atmosphere, warming the planet enough to melt the ice. This reset of Earth's climate may have opened ecological space that allowed complex multicellular life to later flourish. Permian Extinction. About 252 million years ago, Earth experienced the most severe mass extinction in its history, the Permian-Triassic extinction. Vast volcanic eruptions in Siberia released immense amounts of lava and gases, including carbon dioxide and methane. These greenhouse gases warmed the planet dramatically, while sulfur aerosols caused acid rain and destroyed ecosystems on land and in the ocean. Oxygen levels in the seas plummeted, leading to widespread marine die-offs. Roughly 90% of all species vanished, from trilobites to giant forests. It took millions of years for biodiversity to recover, reshaping life's trajectory and paving the way for the rise of the dinosaurs. Dinosaur Extinction. 66 million years ago, a 10-kilometer-wide asteroid struck near the Yucatan Peninsula. The impact unleashed energy equivalent to billions of atomic bombs, igniting wildfires, generating megatsunamis, and blasting dust and sulfur into the atmosphere. This blocked sunlight for months to years, halting photosynthesis and collapsing food chains on land and in the sea. Combined with massive volcanic eruptions in India's Deccan Traps, the climate swung violently. 3/4 of all species went extinct, including the non-avian dinosaurs. This catastrophe cleared the ecological space for mammals to diversify and eventually dominate. Supervolcanoes. Supervolcano eruptions, though rare, have nearly ended life multiple times. The Toba eruption in Indonesia about 74,000 years ago released so much ash and sulfur into the atmosphere that global temperatures may have dropped several degrees for years. Such events blanket continents with ash, disrupt agriculture, and threaten global food supplies. Earlier eruptions, like the Siberian traps or Deccan traps, show how supervolcanoes can drive long-term climate shifts. While not every eruption wipes out ecosystems completely, each one has the potential to destabilize the climate on a planetary scale and bring humanity or its ancestors close to collapse. Black Death. In the 14th century, the Black Death swept through Eurasia and North Africa, caused by the bacterium Yersinia pestis. Spread by fleas on rats and through human contact, it killed an estimated 30 to 60% of Europe's population and tens of millions worldwide. Cities emptied, trade routes collapsed, and entire regions were depopulated. Although not a planetary extinction event like asteroid strikes, it was a moment when human civilization itself nearly unraveled under the weight of disease. The pandemic reshaped societies, economies, and even the genetic resilience of populations that survived. Nuclear threat. In modern times, the Cold War brought the world to the brink of nuclear annihilation. With thousands of warheads armed and ready, a single miscalculation could have unleashed global thermonuclear war. Beyond the immediate destruction of cities, the real danger was nuclear winter. Soot and smoke from burning urban areas would block sunlight, collapse agriculture, and starve billions. Even today, the existence of nuclear arsenals keeps the risk alive. A large-scale nuclear exchange would be one of the fastest ways to end modern civilization and trigger mass extinctions similar to past planetary catastrophes. Thank you for watching this video. If you have enjoyed watching, please leave a like and subscribe, and let us know in the comments if you would like to see more videos like this one.